there, my name's Miss Patel, and today we're going to be answering the following question. How does a DC motor work? Before we do this, though, we should probably discuss, what are DC motors? Well, DC is an acronym that stands for direct current. A motor is a machine that can cause something to move. So a DC motor is a machine that takes electricity in the form of a direct current and causes something to move using mechanical energy. You probably have a few DC motors in your house, like in your washing machine, or making the humming noise of your fridge, or your electrical toothbrush. All of these are examples of DC motors. But to figure out how they work, we have to talk about a concept called electromagnetism. When current travels down a wire, something called Ampere's law tells us that a magnetic field is created around the wire. In this picture, we can see the current traveling in the direction of the red arrow and the magnetic field represented by the blue arrows. The way we can figure out this direction is by following something that's called the right-hand rule. If you hold up your right hand, you can point your thumb in the direction of the current in the wire, as again labeled by this red arrow. So the current is traveling to the right along the direction of your thumb. That means that the magnetic field will be curling in the direction of your fingers, which again is represented by the blue arrows in this picture. When you're talking about a coil of wire or a solenoid, the opposite applies. So your fingers will curl in the direction of the coil of wire, or the direction that the current is flowing, and then your thumb will be pointing in the direction of the magnetic field. Again, the magnetic field in blue, coil or current direction in red. To be clear, you have to coil your fingers in the direction of the coil. So you can't just put your fingers over where the wire is wrapped. It actually matters whether it's wrapped clockwise or counterclockwise along with your fingers. You can see this concept in action here. I have a coil of wire and it's attached to a nail, which is not magnetic on its own. But when I attach it to a battery, a current goes through the solenoid, which magnetizes the nail, as you can see by how it picks up the paper clips. Now that we understand the relationship between current and magnetic field, we can get back to talking about DC motors. In order to understand how they work, we're going to build our own. You're going to need a battery, a coil of insulated wire, paper clips, magnets, and a piece of styrofoam. Here I'm using a 1.5 volt battery. When you're making your coil of wire, try and make it nice and tidy. So first, you're going to set up your paper clips like I have here so that they're sort of arranged in hooks on either side of your battery. One connects to the positive, one connects to the negative terminal. I used an elastic to hold them on better. You want to be able to place your coil of wire between your two hooks so that it can rotate freely like this. The bottom of these arms on either side of your coil loop need to be uninsulated. So you can use sandpaper or a pair of scissors to rub off the insulation. As you can see here, it's usually sort of a copper color. Once you take it off, the wire will be more silver. Current will travel out of the positive terminal of your battery and into your wire loop, and then back down into the negative terminal. Using the right-hand rule, we know that the magnetic field created by this current loop is coming out of the screen towards us. When we place our magnet underneath of our loop, its magnetic field is going to oppose that of the loop, which causes it to start turning, which in turn turns off the current going through the loop because of the uninsulated sections of the wire being moved. It's then going to keep rotating until it gets to the part of the wire that's insulated again, which is going to restart the current and then restart the magnetic field, and therefore cause it to continue to rotate. Okay, let's go over that again. Our current is going to come out of the positive terminal of our battery, through the paper clip, and then into our wire loop. When we have current going through a loop of wire, a magnetic field is created. That's going to force our loop to rotate because of the repulsion between the magnetic field created in the loop and the magnet that's sitting on top of the battery. Our loop is going to flip over, the current will stop because we only uninsulated part of the wire, and then because the loop is already turning, it's going to keep turning, which is going to restart the current again, recreate the repulsion, and the cycle will continue. As you can see, my wire loop needed a bit of a nudge to get started. This one didn't quite do it, but another little push, and once it gets going, this repeated cycle of current turning on and off and magnetic field being created on and off creates this rotation. So what we've done is what we discussed at the very beginning. A DC motor takes electrical energy in the form of a direct current, turns it into mechanical energy. As you can see by my thumbs up there, I'm not touching the wire loop at all. Nothing's touching it. There's no magic going on here. The energy is coming straight out of the battery and being turned into mechanical energy in the form of our rotating loop. Again, there's no magic here. This is the same concept that rotates your washing machine, keeps your refrigerator cold, and powers some electric toothbrushes.